So we are on to 23rd question of the board exam. The question says, verify that the roots of the quadratic equation. So quadratic equation has been given. P minus q of x into x squared, q minus r into x plus r minus b equals to 0. So the roots, we have to verify that they are equal when this condition is there. So q plus r is equal to 2p. Now, we have a simple thing that we know. Roots are equal for a quadratic equation ax square plus bx plus c equals to 0 when what happens? D is 0. Now D is 0 means what? B square minus 4ac is 0. B square is equal to 4ac. So this comes to our mind at the very first. Now when this comes to our mind, we'll do this. Let's try it out. So what is a, b, and c here? I'll quickly write that for you. This term with x square is a. This is b and this is c. I'll just square these things. So that gives you q minus r square is equal to 4 times into a. What is that? P minus q into c. What is that? R minus p, right? Now this becomes, let's just start solving this. Q square plus r square minus 2qr is equal to 4 into, or we can do this as minus we are taking common. It becomes p minus q into p minus r. Doesn't make a lot of a difference still. Let's just write what is happening on the right side. So it is p square minus pr minus pq plus qr, right? And this is what it was, q square plus I square minus 2qr. Now, we just open the bracket. So that will give you q square plus I square minus 2qr is equal to minus 4p square plus 4pr plus 4pq and minus 4qr. Now what I can do is, let's just draw a line. Now I am shifting everything from the right to the left. So 4qr is negative on the right. It will go to the left. It will subtract 2qr, right? So q square plus r square remain the same. 4qr minus 2qr gives you 2qr, right? Plus 4p square. Okay. What else? Minus 4pr minus 4pq. That's it. And this whole becomes 0. Now let's just notice what is happening here. So there is individual square q, r, and p. Okay, p is not individual square, it's basically 2p square. And there is a combination of these two happening. So any two out of these three. So there is q and r combination happening. Okay, qr. There is p and r combination happening. So I'll not say p, it's 2p and r combination happening. And 2p and q combination happening. Also, one thing that you will have to notice very much is that things with p have a negative also, right? Now, what all of this tells us? It tells us that a plus b plus c square somewhere is happening. I'll write the formula for you. And there is individual squares and there is combination, right? Except that what is happening here is that there is q, there is r, but there is 2p and that p is lending a negative. So it should have been minus 2p square is happening. Now you can do this in reverse also, like the thinking that we did here. So now you can quickly check, like if positive works, so positive definitely will not work. If negative 2p is working or not. So let's just try it. A square plus b square, which gives you q square plus r square, minus 2p k square, which gives you 4p square. So these three terms are ticked. What else? Next is 2 times of ab. So qr, okay. qr has a 2, yes, that term is covered. Q and 2p, right? bc. So bc is r and 2p. So minus 2pr and ca. So minus 2p q. And as you can see, everything is formed. So this is just a slight verification, which we should not be doing because we were pretty confident that we had all the terms. So q plus r minus 2p raised to the power 2 becomes 0. Now, if that is 0, right? So q plus r minus 2p has to be 0. If that's the case, that is what the condition becomes. Q plus R is equal to 2p. So now this is method 1 of doing it. Is there any alternate method that we could have done this? So yeah, there is an alternate that we could have thought of. So I'll write the alternate. Let's just discuss that, what we could have done. If you look at the equation, I'll just copy it down. P minus Q x square Q minus R times x plus R minus P equals to 0. So we have this at the back of our mind that uh, if there is an equation which we can assume that there is some root to it, and most preferably 1 minus 1, 2 minus 2 kind of. So we will be able to solve it really easily in that case if it fits, right? And here in this case, if you check for x equals to 1, right? Let's just check it. Put x equals to 1, and what you get it, p minus q plus q minus r plus r minus p. If you sum these up, there is a plus q plus r minus r and minus p plus p. It actually becomes 0. Implies x equals to 1 is a root. Now, if that is a root, you literally have hit a jackpot. Now, what's that? So what you have gotten is that uh, you know the sum of roots and product of roots. So sum of roots is what? Minus b over a. Now minus b over a becomes what? It is r minus q over p minus q, right? And x equals to 1 is a root. Also, it has equal roots. If you just check the question once, verify that the roots are equal when this is the condition. So you know that it has equal roots. Also, d is equals to 0 implies roots are equal. Now, with this information, you are saying x equals to 1 is the other root also. So the sum of roots is actually 1 plus 1, which is 2. So what you get finally is you just have to solve this r minus q over p minus q equals to 2, implies r minus q is equal to 2p minus 2q. If that's the case, let's just take 2q on the right side. Left side, r plus 2q minus q becomes q is equal to 2p. Now, is that the condition that we are required to get? Q plus R equals to 2p, yes. So that's your method 2 that gets you the answer, except you have to be able to imagine this part. So with both the alternate methods, you have this thing that you will have to think a bit when you are reaching the answer. In method 2, you have to think in the starting, what can be a root of this? What can you assume which will be really good for you? And then there is one thing that helps really is that PQR are written as a cyclic thing, right? So if you check, P minus Q is written, then Q minus R is written, then R minus P is written. So if it is written in a cyclic manner, most of the times one is going to be a root, right? So this is something that you can take away from the solution. I hope you were able to solve this and get your marks.